rethinking ASP templates. Okay.
Okay, many thanks. So, I would like to, to start in a strange way. So it's not a paper about chess. If you have no idea about chess, anyhow, the example will serve for what I want to convince you. So if you consider this state, okay, so this end game, let's say, one can say, but the black has a queen, so he's going to win against the knight. But if the white is going to move, the white move in this way, and after the white moves in there, it does a check on the king, so the king must move, and then the knight is going to capture the queen, and then it's going to be a draw. Okay, so even if the king doesn't capture the knight, it's going to be a draw. Now, if we add more pieces, the problem becomes a bit more difficult. Now we have two knights against a pawn and a queen, but again, if the white is going to move, the white is going to move the knight here, and now very likely the black has to capture, or anyhow, even if moving doesn't change anything, because after this move, if the black capture, the other knight is going to capture the pawn, fork the two pieces, and gain the queen. So again, it's a draw. If you add more pieces, one rook and one rook, again, if the white is going to move, here the white is in trouble, so it must go to those states. So try to capture the rook, then the black is going to capture the rook, and you are back to that situation. Okay? Now, chess, it's a really complex game. Why? Because you start with 32 pieces, not 2, 4, or 5 pieces. 32 pieces that you essentially cannot isolate. So all of them can interact with one another. It's different from checker. In checker, all the pieces move in one direction. So there is something you can assume. In chess, you don't have this kind of assumption. Every piece you have in the chess board possibly interact with each other. And then, for example, you have to start studying all the pattern, gambit, tactics, strategies, and so on. And anyhow, so why, even if there are centuries of this game history, there are only around 2,000 grandmasters all the time. What about the other players? We essentially suck, right? We try to move our pieces in the chessboard. But now, software programming should be different, but it can be very similar. Okay, so software programming, it's like a chess game if you don't have an isolation mechanism, and everything can interact with everything else. So if every line of code that you are adding to a program possibly interact with all the others, you are in a chess game. Okay? How many rules can you handle in this way? How many lines of code? 32, like in chess? But we want to deal with programs that are much larger. I don't remember how to remove the... Now, big problem, okay? I'm mainly an ASP guy. Okay? In ASP, there is no isolation mechanism. So every time I encode in ASP, I feel like I'm playing a chess game. It's a big problem, okay? Not everyone is an ASP grandmaster, okay? So what about the other programmers, okay? We would like also them to play the game, right? So, and enjoy. So what's the problem of the lack of isolation? It's difficult to reuse the code. Okay, and then it's not because in ASP every time we have different programs, because if you consider having an undirected graph and checking that it's connected, you are going to very likely write 3 rules like this. So you start with a node, let's say the first one according to some total order that the ASP engine is going to provide. Then you compute the reachable nodes in the relation edge from that node. It's a recursive rule, and then you finally check that you really reach every vertex. Now, take another problem. You have a tree, and you want to check that it's not a forest. Obviously, it's the same program. The only difference is that you use a node instead of vertex, and you use a tree instead of edge. But the program is the same. Okay, so why you want to write again? Now, if there is a methodology in ASP at the moment, is that you search for a similar problem. If you are lucky, you can find one, and then you start to do what? some regular expression or manual renaming to map the predicates and say, okay, instead of vertex, I use node, instead of edge, I use tree. That's very, very dangerous. And you end up with something like this. Okay, your dream program, but obviously that's a wrong way to code. Why? It's not that you don't use copy and paste in programming. Everyone starts from a code base of another guy. The problem is, if you copy code from other guys, you have to understand it. You have to go line by line and understand every single line. But this means that you can't really copy from a grandmaster unless your level is comparable with a grandmaster. And let's be honest, the encoding that we usually see in ASP are something like this, where we use very short predicate names. We have rules that maybe they are not immediate to catch, and we can understand this already from the fact that there are more comments than code. Which other programming language has more comment than code? Assembly. Okay, so maybe ASP is an assembly language, obviously in its context, in combinatorial search and optimization. Now, in software programming, in the other languages, how you master the complexity of the software? You rely on invariants, okay? So what is an invariant? It's a simple definition, okay? It's something that doesn't change. Example, in C. You get a lot of invariant from the type system. You get a lot of invariants from the notion of scope of a variable. For example, in this function, I know that this function is going to return something that is not negative because the type is unsigned. It's going to receive a number that is not negative. Then I also know that this variable is declared inside, so if you refer res outside of this function, it's going to be a different portion of the memory, so you can't refer this variable outside. And now you can conclude, after this calculation, the function is going to return the factorial of n, but only under the assumption that n is smaller than 13, because for otherwise you're going to run in an overflow. And then the output is going to be, we consider unpredictable. Okay, obviously you can do the calculation, but you don't want. So this means if you stop with this level of coding, every time you use this function, you must also check that n is not small, is smaller than 13. For otherwise, you should not call this function. You should do better than this, right? So in clean code, in a clean code approach, since this variable crosses the trusting boundary of this function, you have to check. Maybe you check inside, and if you don't meet the condition for avoiding an overflow here, you raise an exception. Okay, now this means that here I have an invariant. N is smaller than 13, no overflow is possible, all these operations are safe. And now I can conclude, yeah, it's going to return the factorial of n, or it's going to raise an error. And then that's another nice invariant we have in our code. We don't need to work, I would say, if we forget to do the check outside, it's fine, because we are going to get an error. It's a fail-fast approach. We notice the bug and we fix the code. How? With a try-catch. Very easy. So we would like to have invariants. But invariants in answer set programming. An invariant is something that doesn't change or vary. ASP, one of the strengths is the non-monotonic reasoning. And non-monotonic means that even the entailment relation changes. Not in one direction, but in all the directions. You can remove some previously conclusion. So how much can you guarantee that doesn't change in an ASP program? Not a lot, okay? And let me say that it's not even just because of the non-monotonicity, it's because of the lack of isolation. So in our example, maybe we were assuming that this predicate vertex is not modified outside. For otherwise, this encoding doesn't work. But we don't have any linguistic construct that will ensure this property. What about edge? We also assuming is not referred outside, is not extended further after this line, but there is no linguistic construct that restrict the program in this way. What about reach? This is even more important. Here, with these two rules, I'm getting from this first vertex all the reachable nodes in the edge relation, but I don't have any way to say that nothing can be added to this reach relation. So if by mistake I'm going to expand this relation with another rule, I will get some unpredictable result. And now, another big question. If you don't have an isolation mechanism, what you are going to test? Because anything you are going to test on this program, there is another rule that will be added in another 2-3 lines that will destroy some assumption you were having. So there is no notion of unit. And then the other big question is how to teamwork if you can't isolate your code. Let's consider this example that we have also in the paper. So you are given a graph. The graph represents cities, let's say, and the edge represents road segments. You want to build an highway, so you must promote some of this street to be the highway. You don't want to have more than required, so maybe you need a spanning tree of the graph. And additionally, for each spanning tree, you would like to understand what happens if you close one segment. Okay, so obviously you are splitting the network in two portions. The absolute difference between these two portions is going to give you the impact of closing that segment. Okay? So you would like to have this data in order later maybe to take a decision, or maybe there is a bigger program that where you want to do something. Now, very important, it's clear here that the problem can be split in two parts. You compute a spanning tree, then given a spanning tree, you close a segment and see the impact. So if you have two teams, you may ask them, okay, please work in parallel, okay? So one of you is going to do the spanning tree, the other is going to start from the spanning tree, represented the relation tree, and is going to do the impact. Okay, let's say that the team alpha is taking care of the spanning tree and build this kind of program. So the first rule, yeah, it's link. The graph is undirected, so let me do a symmetric closure. The second rule is guessing the tree. So if I have n vertices, I need n minus 1 edge in a tree. But this can also be a forest, so I close symmetrically and I apply the program that computes the reachable nodes and check that it's not a forest. So, super happy. You can try test on a few examples. Given an undirected graph, this program is going to give you a spanning tree. It works. Meanwhile, Team Bravo is working on the other program, and essentially the guy says, okay, I'm going to receive the tree in this predicate, so this is my input. I'm going to guess one of these segments to stay out. Everything that is not out will stay in the network. Now I need to apply the reachability, and then I'm going to close symmetrically because it's undirected. And every node that I reach from this initial node is going to stay in one part of the network. Everything that I don't reach is going to be on the other side of the network. So the impact is going to be the absolute difference between these two values. So again, you can start with a few examples represented in this tree predicate, and you will get what you want. Okay, you can enumerate all the solutions. So again, super happy. Now, you have two working programs. You put them together, and you end up with something that doesn't work. Okay, why this stuff doesn't work? For many reasons, but let's see. An easy to see problem is that here we are using reach, actually reach 1 over 81, with a meaning, and here it's used with another meaning. And these two definitions are going to interact with one another. Oh, one can say, okay, I'm going to rename one or the other. Yeah, but this means that either you have to discover from the bug, or whenever the team alpha decide to use the rich predicate, it must do a call to the team Bravo and ask, please don't use the rich predicate because I'm using it internally. But this is a synchronization point. Okay, so what you do when you do parallel programming and you have too many synchronization points, you just go sequentially. The parallelism doesn't pay off if you have too many synchronization points. Now, if for every predicate you have to introduce, you have to call the other teams, and there are maybe another 10 teams, give up, okay? Okay, but let's say this problem you can fix by renaming one of the two predicates. There is another problem, a bit less evident, that it's with the predicate 3. So on this side, at some point, 3 was closed symmetrically. Here, it was assumed to be without duplicates. So if there is 1, 2, there is not 2, 1. So this problem maybe you can fix by adding this condition in there. But you see, again, it's quite easy to do mistakes. Now, how to fix this kind of problem? Okay, so a younger version of me will destroy completely the language and say, okay, yeah, nothing works, let's start from scratch, okay? But now I got some experience, I know that this approach doesn't work. You need something gradual, okay? So you need a fix that slowly is gonna solve the problem. So let's consider a simpler example. So you just will look for the nodes that are reachable from an initial node, okay? So in a relation edge, and you move to this other. So what can be a solution that I suggest? Okay, so maybe there is an ASP grandmaster that wrote this kind of rules in a proper way, testing, super efficient, and so on. And then the grandmaster will tell you, look, you can use this template that computes the reachable nodes from the relation, in the relation reach of arity1. Reachable nodes from where? From a starting node given in this predicate, start of arity1, and the relation itself is encoded in this other predicate, link of arity2. Now, the template itself is going to be something similar to this or something else. It's something that the grandmaster is going to decide. Now, you trust the grandmaster, you read the description, and then you say, okay, I need to compute the starting node that I have to place in this predicate, so let me compute this. It's the first rule, essentially. Then I'm going to apply the template, and then I will tell you, I would like the starting node to be in the start predicate. This is implicit. The relation link, actually for me, is the relation edge, the one I'm interested, so I want this mapping. And the result I want to have in the rich relation. Again, it's an implicit thing. You do a transpilation from ASP to ASP, and you end up with a program that is essentially the first one. But now you can reuse. Okay, so if you want to obtain this program, now you compute the start node, and then you apply the template and say that you want the reachable nodes from this starting node in the relation 3. You transpile and obtain essentially this program. Okay, so we are at this point. Okay, so we are already reusing code from other guys. But now one can say, okay, look, the first rule is very similar to these two use cases. So maybe we don't want to repeat ourselves. Let's dry the code. Okay, so if I spot something that can be usable in 2 places, maybe it's going to be usable in another 1,000. So if I want, I can define my own templates. And let's say I define a template that, given a relation of arity1, is going to provide in this predicate first, the first element in the relation. How I implement this with this rule, and now I can reuse and say, okay, look, I want to apply this template, the first the output, the first predicate, for me is going to be the start. The relation I'm interested in is the vertex. You transpile, and you still obtain this code here. Similar for the other, okay? So the relation is node. Already in this one-line template, there is something really interesting. There is an aggregate inside the template, and also this aggregate is assuming a property of the ASP engine that every term is comparable with every other term and there is a total order relation. So what's the result? The result is that you can use this template without even having an idea of these details of the solver or the linguistic construct of that it's the aggregate. So there is an isolation of the complexity of the language. And you don't need to understand it. Or if someone wants to change this implementation, and instead of using the aggregate, using something else, all this other portion will stay the same. Okay, so you will have an effect in the transpiled code, but maybe maybe some grandmaster improved the template. It's a one line. Imagine if it's 5 lines, okay, or 10 lines. Okay, now actually, this start predicate, it's very likely an auxiliary symbol, so I don't see in the original program. So maybe I want to avoid external references, so maybe it's time to isolate. How isolation is achieved in Python? So if you start a method with __, it's going to be considered private, and it's actually going to be automatically rewritten. Now, if this stuff works in Python, there is no reason why this should not work in ASP. So if you define in a template a symbol that starts with __, it's local to the template. If you refer the same symbol inside the same scope, it's going to be the same symbol. But for outside, you can't refer because we are going to rename when we apply the template in a random way. And there is no chances that you are going to refer this symbol, unless you see the transpilation, but you can always shoot your foot. Now, if in a different context you use __ start, it's the same name, but it's a different symbol because the automatic renaming is going to assign a different name in the transpiled code. So let's go back, okay, so to the problem of the spanning tree. So to fix this problem, you need a time travel device to explain to myself that something is not working, that we need the notion of template, predicate renaming, locality of symbol, and how to obtain this. And then maybe you can come out with some starting template and say, okay, symmetric closure we already wrote several times, so maybe it's better to define a template. Reachable nodes, why not? We are using several times. The notion of connected graph, maybe you need a starting node, this is going to be isolated. Then you need the reachable nodes, but you compute from this starting node and you compute in a hidden symbol, reach. And then finally you check, okay? So now you see this symbol, if you refer outside, is going to be a different symbol. Spanning tree also, very likely. There are several guys that will need at some point a spanning tree of a graph. Why you have to restudy how to implement in ASP? You can implement a template for this, and then maybe you are going to close symmetrically the link relation on itself and compute the spanning tree. You do the transpilation, and you are ready to send this stuff to Bravo. Now, this transpiled code is plain ASP, so this means that Bravo can use without having the transpiler, and it's very unlikely that Bravo used this symbol in its encoding. Indeed, if we consider the encoding provided by Bravo, and we have to use this because we used that TDD, we went back in time, and we haven't interacted with Bravo, so its line of events is the same, so it's going to end up with this code. This doesn't clash. But you see, already in the code of Bravo, there is a lot that can be reused. So that's symmetric closure. Here, reachable something. Okay, this stuff we can put in templates or reuse some templates. Very quickly, for another problem, fighting with the gang of Billy the Kid, that's a problem from a contest. So you have a graph encoded by these two predicates, a length. You want to guess a number of towns such that every path of the given length touch at least one of these selected nodes. Solution of the winning team, it's something like this. All the paths are materialized with an interpreted function symbol. That's my face every time I look at this encoding. And the interesting thing is this is the winning team. And the solution is actually a solution of mine. Every time I have to restudy. Template-based solution. You want to close symmetrically the connected relation. You want to adjust the length. Then maybe you will have a template from a grandmaster that is going to compute from a graph encoded in these two predicates, all the paths materialized in these two predicates. And finally, you want maybe to discard duplicates. Again, you can reuse a template that some grandmaster brought. And finally, you check. That you touch in all paths at least one of the selected town. What these templates contains? The answer is not important, okay? It's precisely what you don't want to see. But if you are really curious, I can show you, okay? But most importantly, this encoding I wrote in 2019, we won, period. Nothing more we can do with this encoding. This template solution, I can understand also in another 10 years. And it used an interpreted function symbol, but indirectly, because the interpreted function symbol are hidden here. So this means that even someone that starts learning ASP can already use this template, even if they have no idea about function symbol. And these templates can be reused again and again. Now, for the testing, very likely templates, since they have an isolation mechanism, can be a good option. We have a few properties based on the logic of here and there that we can exploit, but you can use any library, okay? And actually, we want to use PyTest for this stuff. And I don't know, if you want to try this stuff, just create a poetry project, add the dependency Dumbo ASP, and then it's just super easy. Parse a program, get a model, expand the template, and so on. Now, I want you to try the Dumbo library, maybe write template, if you are a grandmaster, also for other ASP user. Local names can give us invariants. The invariants we can use to build up our complex software. And then the idea is that we would like to test the templates. They will be the unit. Okay, there is a lot to do. Maybe in a debugging session, you would like to have a meta interpreter in order to track the program. It will be slower, but for a debugging will be good. We want to build at-term libraries, so maybe also renaming of at-terms, or maybe optimize some predicates that appears only once, or maybe sub-rule templates, like a conjunction, okay? But slowly. Thank you.
Questions anyone has? So I guess the library of templates you said is available for people to use?
Yes, it's part of this Dumbo ASP. It's on PyPy and GitHub. So one can easily add the dependency, and then you see, that's a wrapper around the Klingo Python API. So if you want to parse a program, you use this factory method, symbolic program parse. You get the program in this variable. Then if the program contains template or application of templates, you can also define a template here. Then you call template expand program, and you get a new program that is the expanded version. After that, if you want to compute the model of the program, you use a factory method of the model class. If you want, you can filter with functional programming. Then, for example, you can print in there. Or if you want, you can also pack a recipe with ASP chef. It's just a URL. You take the URL, you put in there, you give the model, and you get some kind of visualization. Now, my Ubuntu is broken, so I have to copy the link. You should get some result like this. Okay? So you see, that's another use of ASP Chef. So you can prepare a recipe just for post-processing. So maybe you can also hide a few details if you want. Where is, okay? Maybe if you don't like to see these other panels, you will hide them. Then you take this URL, you replace in this code, Next time you execute the code, the model is going to be shown in this way. Okay, and then you see, that's, in my opinion at least, it's much more readable than the usual ASP representation, textual representation. 3, 3, 3, 3, 3. You have to draw the 3 using pencil and paper. And the alternative is that you prepare a recipe and you see in this way.
Okay. Any other question? Okay, well, thank you. It's time
Thank
for
you.
the coffee break. Right? Yeah. Oh, no, there's one more talk. Sorry. There's one more talk. Yes.
Thank you.